Hello hackers! Today we'll be looking at Binary Ninja, which is a decompilation tool meant to analyze binary files. So, the first thing we need to do is go to Home, go to Challenge, and for every x86 challenge there will be this C image file right here. Now this is called a binary file, and how you would normally load this is you would load this in a decompiler to see exactly what is going on in the binary. If you tried to open it normally, it would just open to a bunch of garbage. But let's open this using Binary Ninja, our tool of choice. What we do is right click, click Open With, and I already have the option for Binary Ninja here, but if you don't, you can open with other application, and then you can scroll down and find Binary Ninja down below, or it'll be at the top here. So let's open it with Binary Ninja. Now click Start, and you will be met with this screen right here. It may look a little different, but let me full screen this so we can see. Alright, there we go. So this is Binary Ninja. As you can see, there are a lot of tools available to us to analyze the binary, including a pseudo C code breakdown, a list of all the memory addresses and functions, and other fun stuff. So if we want to start analyzing this x86 binary file and see exactly what is going on, for pretty much every single challenge here, we will have a main function. So go to the symbols list on the left here, excuse me, and scroll down until you find this function main right here. And we will see that main is right here. And this is basically where our entire program starts execution. So we have a whole bunch of variables being defined here, and we have a whole bunch of comparisons being made, and lots of crazy stuff. Now at first glance, this might look really confusing, but let's break it down using a very simple method, which I like to call reverse engineering. And what I mean by that is, you see there's actually another function here called win. This win function prints out the flag. This is your goal for every single challenge. So in order to figure out how to call this win function, we take a look at main and we scroll down until we find, there it is. We have a win function being called here. This is our end goal in every single Binary Ninja execution. We want to get to this win function so that we get the flag printed out. So let's work backwards from here. We have one comparison here, and we have another comparison here. Now, there is some functions going on here. Let's see. If argument 1 is greater than 1, cool. And if this whole thing is being string compared, and the last 5 characters of your file have to be .cimg. If it isn't, then it'll print error invalid file extension and it'll just exit. So already we can get our first clue here. It looks like our file that we submit to cimg, or the binary, has to end in .cimg. So we can easily solve that by naming our file something .cimg. It can be like, the beginning part can be anything. I won't go into detail on how to solve the challenge because that's outside the scope of this video. I just want to show you guys the general process in using Binary Ninja. Now, we read the header in here. If it doesn't, then there's the error, but let's assume that it does. Next, there's another comparison going on here. Now, what is this var24? Variables in Binary Ninja are usually represented by some offset on the stack. You can see the stack offset 0x24. So that's the place in memory where it is being read from. We can put that aside for now, and let's just take a look at the comparison being made here. So it looks like it reads the first byte in var24, checks if it's not equal to byte 63, or that same variable at position 1 is not equal to 4D, or position 2 is not equal to 36, or position 3 is not equal to 33. Now it looks like it's doing a whole bunch of byte comparisons here. inside of the file. And if none of those bytes match up in the correct positions, we will get an error saying invalid magic number, and it'll exit. So that's another key to solving this challenge, is to take a look at what comparisons are being made here, seeing what the error message is, and perhaps working backwards from there as well, in the spirit of reverse engineering. Now, assuming we pass both of these checks, we should be able to call the win function, which is our goal. Now, that's essentially the process of how I like to go about in this reverse engineering module. Let's take a look at some other neat features of Binary Ninja. I believe by default it starts you off with high level IL. This is more of a intermediary between pseudo C and full disassembly, which is just straight up assembly instructions. What I like to do is I like to cement myself in pseudo C because it is the most readable out of all of these, and I think it is the most easiest to understand. If you're having trouble figuring out what values are being stored here or what's being compared, you can always click on this top window right here, where next to ELF, linear, and pseudo C, and this dropdown will change the type of disassembly that's happening. So we have pseudo C, high level IL, low, medium level, low level, and disassembly. You can't do low and medium because this is Binary Ninja free, but you are allowed to do pseudo C, high level IL, which looks like this, and disassembly, which is just pure straight up assembly instructions. Now you can see, let's go back to pseudo C. Let's look at this comparison being made right here. If you ever wanted to check what a certain line is doing in assembly, you can just click on that line right here, have it highlighted like this, and go up top here, change pseudo C to disassembly, and we should have the highlighted line with the equivalent instruction set. There might be more than one instruction associated with that C function, so just look up and down in either direction, and looks like we need to look up because all of these comparisons are being made up here. So it looks like the first position byte in var 24, which is some value on the stack, is being compared against byte 63, then the next position with 40, the third position with 36, and the fourth position with 33. So that's how you can translate the assembly instructions into pseudo C. Because if we switch back to pseudo C, this is essentially what's going on. It's the same thing. Now, if we want to look at program flow, we can change the type of disassembly here. We have byte overview, graph, hex editor, linear, memory map, all of these fun stuff. Byte overview is that, which is really confusing, and we cannot read that. Let's look at graph. Graph shows us basically the control flow of the program, essentially what is going on, and where each jump leads to, and if there is a jump or there isn't a jump, there are all arrows leading from one box to another. So this is also helpful for seeing what happens when a jump is being taken versus when a jump is not being taken. If we look at hex editor, we have just a hex editor right here. We can edit these hex files any way we want. This is basically the data inside the binary. In some challenges, you will have to edit binary or the hex inside the binary. And the way to do that is you click on any byte. At the very, very bottom right corner, there's a lock button right here. I don't know if you can see it, but it'll say unlock the file to allow changes. So if we click on this lock, we can actually edit any of these bytes right here. So let's say we want, this is byte 61, we can change it to 59. Now it's a capital Y. Well, we don't want that, so let's change it back to 61. And once you're done editing, you can click the lock icon again to save your changes, and it'll be just like that. Next, linear was the mode that we've been using this entire time. Let's go back to main. Now linear mode is what we all know and love. It's just normal Binary Ninja, normal disassembly. This one will probably make the most sense, and I would recommend you stick to this for most of the time. Linear and graph are the most useful ones out of these. I wouldn't really use any of the other ones, except for hex editor in those challenges that you need to use the hex editor. Now you can see right here on the right side, we have a big column here, which is just a bunch of different data. We can scroll up of it, we can scroll down. A whole bunch of these values are being stored here. But what we really care about is the stuff near the middle in this blue zone. Everything else is mostly data that we don't care about too much. I wouldn't use this to navigate though. Please use the symbol chart on the left hand side to navigate functions. And there's also an option to choose between ELF or raw. Raw looks like this. It may not be nice to look at, but it is the most basic bare bones view. But I personally don't like that, so let's just switch back to ELF and go to main. Now that's an overview of Binary Ninja. I hope you guys enjoyed the video. If you have any questions, feel free to let us TAs know. You can ping the TAs if you have any questions about Binary Ninja, or head on over to Recitation. This is a hard module, so the more resources you guys take advantage of, which is TAs, recitations, these videos for instance, the more you'll be successful in reverse engineering. And see ya. I hope you guys have a great day.